Hey guys, what is up? This is Matt with Comax Gaming and welcome to another C++ tutorial. So today I decided to go with C++. I know I haven't done a video in a while and I'm sorry, I've been busy. I've been doing a project which didn't take all the time, but it's something I've made and I think it bugged. It's a foreign line. I don't know if you could call it that way in English, but basically you just gotta stack 4 of your things, I don't know the name, in a line to win. So the game is in Spanish because my main language is Spanish, and this is basically how it goes. I want to show you guys how it works because we will definitely be making one of these in the future. As you can see, you move your thingy with the arrows and then you drop it with the down arrow, and basically, well, just drop until you win. Of course, it's not only vertically, you can do it horizontally and diagonally, and you can save the game and stuff. So yeah, it's a pretty cool project. I haven't used any libraries, so it's kind of complicated to do without any special libraries, but it's not impossible. It's way easier with libraries, of course, but yeah. So today what we're actually gonna be learning about is pointers. Now I was gonna do arrays, but I decided to go with pointers first because arrays are pointers in a way. So if we learn this first, we'll be able to understand arrays better in the future. So basically what a pointer is a data type of an address or a variable that points to another variable, but it only contains the address of that memory, of that pointer, of that variable. I don't know if you know this, but every variable in C++ and in every other programming language takes space in the RAM memory. That's why we to play like complicated games, we have to use more RAM and sometimes more graphics card requirements, because as far as the graphics are concerned, it takes VRAM, which is the video RAM, and then it takes RAM for the other files and variables, and everything you create, it goes to the RAM. So if I create an integer here, int whatever, now I'm currently taking 4 bytes in the RAM memory. So this takes 4 bytes. As you can see here, guys, I found the short integer, not the normal integer one, and as you can see, it takes 2 bytes, which is the shorter version of the integer, which looks like pretty much like this. Short int, and basically it's gonna be a bit smaller and it won't store as many numbers. But yeah, as you can see, everything takes space in the memory. So now what this means is that this variable here is going to have a specified address, and that address will not change unless we restart our program. That address is going to be permanent during the variable is going to stay in the memory as long as we have our program open. Only if it's a global variable. If it's a temporary variable, which means if it's in a function maybe that's going to be called and then killed, the variable is going to be removed. But as long as we keep the program running and the function which contains the variable running, that variable is going to be stored in a specified address and that will not change. So if we have our variable poop, for example, and make it equal to 5, and we want another variable maybe to point at this, we can do it this way. Int the star or the asterisk or whatever you want to call it, and then another name, I don't know, maybe, I don't know, hello, hi, or he, and you make nothing. I recommend initializing all the pointers with null, just in case, because if you for some reason you do it wrong and maybe forget to do something, then this can pretty much break your whole program. If a pointer is pointing at nothing at all and it's not null, then we have a problem. It can really break everything. However, once we do this, what we're gonna do is type he equals ampersand poop. Now what the heck does that mean? I'm gonna show you what will happen if we print out this message. It's gonna be way easier to see this, guys. Okay, there we go. As you can see, if we print poop, it's gonna print out 5 because that is the value of poop, 5. However, if we add the ampersand before the variable name, as you can see, we get this whole weird thing, 0x28ff44. Now this is a hexadecimal number, and hexadecimal numbers are used to store variables in the memory. So this right here is our address for this memory. Now if we restart the program, let me restart it. Oh, okay, it broke. Well, it hasn't changed, but it usually changes, maybe because there's no program actually doing anything in the background, so it's not moving the offset. But whatever, not important. The important thing here is that we can see what the ampersand does, and it's give us the memory point or the memory address of this variable. Now maybe you're wondering, okay, and why don't I want this? Because remember how we did in the previous tutorial that we passed to a function, maybe void hey, and we're gonna receive an integer actually. If we do void hey and we print out cout a, cout a plus plus, well, plus plus a. But we're gonna do here cout poop. Now if we do the following, hey a, maybe we're saying, okay, this is obviously gonna print out 5, 6, and then 6 again, because we're sending the variable and then we are receiving it back with the changed value. Oh my god, I need to define it. Derp. There we go. Oh my god, what do you want? I'm an idiot. I am an idiot. Okay, there we go. As you can see, well, you cannot see it that very well, but we get here, we print 5, which is the value of poop, then we add 1 to a, we print it out, which is 6, and then we print poop again, which is 5. Maybe you're saying, okay, but I added 1 to the value. Yes, but only to the variable in this scope. So when we try to escape this scope and go back to this scope, our variables change completely because they are not the same. This is called passing by value. Now if we add this, not that this, the pointer mark or the asterisk, and we execute the program again, we're gonna send actually we can send poop here. We're gonna change this bit and we're gonna do he here, and we're gonna press continue. As you can see, we print out the memory indexes, and that's fine because we print out the memory addresses because this is a pointer, not a value. However, if we add the asterisk, and here we add the asterisk again, as you can see, we get 5, 6, 6. Okay, you must be completely confused by now, completely. When we pass it, when we start the program, we have this variable poop indexed or initialized at 5 with a value of 5. Then we do int asterisk, which means pointer he, and we make it equal to null to avoid any problems. Then we make he equal the address of poop, so he is gonna point directly to poop. Then we call the function hey, which requires a pointer because we have the asterisk. In this function, what we do is print the value of the pointer. Asterisk means value of. So he is pointing to poop, and the value of poop is 5. Therefore, this is going to be 5. When we get to the next line, we add 1 to the value of poop, which means that 5 is going to be 6. And that's the point of passing by reference. Now this is called passing by reference when you send it with an argument, with a pointer. When you send a pointer, it's called passing by reference. You can change or modify the value of a variable outside of the function where it was defined in. So you can send this pointer to anywhere in this code. Maybe if you have a 1000-line code, you can send it anywhere. And if you send it with this, with the asterisk, you can change the value of poop anywhere. And that is very convenient in some cases, guys. Now maybe you're wondering, instead of saying he, can we send poop, the address of poop? Yes, it's the same. It doesn't matter because it's a pointer, and that's what we're asking. As you can see, we get the same exact result here, 566. And that's the point of passing by reference or using pointers, guys. I know this is very confusing and you might not understand everything today, but we're definitely gonna get into this in the future. We're gonna use it a lot because this is very useful in many cases. And yeah, I hope you understand. If you did enjoy the video, please rate it up. It helps a lot. Please subscribe to the channel if you haven't already, and I'll see you next week.